So someone is trying to join there. Let me see. Have I admitted the person in? Okay, so we were having an introductory session on physics for today. So I hope you can see the screen, right?
Yes, sir.
Okay. Oh, someone wants to join this session. Let me admit the person. Uh, okay, so we'll be looking into physics today. So physics is also one of the important aspects of sciences, just as the other two ones that we've talked about, the chemistry and as well the biology. So and it's not possible you want to talk about physics that you won't mention or that you won't go through physical units and measurement, which is an important area as far as physics is concerned. So physics as a science is the study of matter with in relation to energy.
Energy.
So that is a physics definition. Study of matter in relation to energy. And remember chemistry definition, study of matter, nature, properties and composition. Why biology, study of living things. So you need to know those definitions, you need to remember them. Yes, so today we're looking at physical units and measurements. I hope we can see the screen.
Yes, sir.
Okay, so we we continue there. So first thing first, in physics you must be able to measure. You must be able to measure uh, physical quantities, because physics itself, from the word physics, you know, there's no how you won't do with physical quantities. And what I mean by physical quantities, you're talking about fundamental quantities and derived quantities. Okay, so someone wants to join the session. Let me grant an access. Uh, okay. I think I've done that. So how do we measure? Why do we measure? So you think about it. How do you know your height? How do traders know the amount of rice you're selling? How do we know how fast a car is moving? How do doctors know a patient's temperature? So yes, we need to measure so that we can have an accuracy of what exactly we are talking about. So every day we measure things around us. So physics is a science that studies matter, energy, and its interactions, as you can see here. So to study physics accurately, we must be able to measure quantities correctly. And this is why physical units and measurement is one of the most important topics in physics. Yes. So let's continue from there. So in this session, learning objectives, what you will learn, you should be able to define and explain and define measurements and explain the importance of measurement in physics, define physical quantities and understand what makes a quantity physical, build foundations, understand what measurement forms the foundation of all physics. Every physical quantity must be measured with standard units for accuracy and consistency. You must also be able to classify quantities. I'm not here. be able to differentiate between fundamental and derived quantities, state the SI units of common physical quantities, and use unit prefixes correctly, and also apply the knowledge that you've learned. You must be able to identify common measuring instruments for different physical quantities and match the right instrument to the right measurement task. So right on this screen is the learning objective, what you are supposed to know at the end of the session as far as physical units and measurement is concerned. Okay, so that's about that. So let's continue. So measurement and physical quantity. So what is measurement itself? It is actually the process of comparing an unknown quantity with a known standard quantity of the same kind. Examples: measuring length with a ruler, mass with a balance, time with a clock, temperature with a thermometer. So what is the physical quantity? You have these basic definitions here. The physical quantity is any quantity that can be measured and expressed with a number and a unit. So you must take note of that. A physical quantity must have a number, kind of a magnitude, and then there must be a unit attached to it. So every measurement has two parts: a numerical value and a unit. So for example, if I tell you that, oh, what is your weight? So you tell me that, oh, my weight is 65 kilogram. That 65 kilogram you've mentioned is a physical quantity. Reason because it has a numerical value, which is 65, and it also has a unit, which is the kilogram there. So, and also in physics, unit is very important. I can't ask you for your weight and then you just tell me 65. Give me just 65 does not show accuracy, because 65 could be anything. So you want to attach units to be specific. Yes. So here 20 is the value, 20 is the value, and kilogram is the unit. So what is unit itself? A unit is a standard used for measuring a physical quantity. So when we say a table is 2 meters long, the meter is the standard unit. Yes, the meter is the standard unit. So scientists basically they use what we call the SI system, which is the International System of Units. So we are going to talk about those SI units shortly. So fundamental quantities. These are fundamental quantities here. We said quantities that cannot be expressed in terms of other quantities. And you should know that there are seven fundamental quantities. Let's look at those 7 here quickly. So 7 fundamental quantities. You must know that there are 7 fundamental quantities. So 1, you have mass. 2,
length.
You have length. 3, you have time. 4, you have temperature.
Amount of substance.
Okay. 5, you have amount of substance.
Luminous intensity.
Amount of substance. 6, you have luminous intensity. And 7 is what? Electric current. So let me quickly grant an access to the person trying to join the session. Okay, so these are the 7 fundamental quantities which we are very much familiar with already. Yes. So mass, length, time, temperature, amount of substance, luminous intensity, and electric current. So these are quantities that cannot be derived from any other quantities. That is why we call them fundamental. Cannot be derived from any other quantity. Okay. So that's fundamental. So example of physical quantities you have on this side. So length 5 meter, mass 10 kilogram, mass time 30 seconds, temperature 25 degrees Celsius. So without measurements, scientific experiments would not be reliable. So you can see all of these quantities here having different units attached to the numerical value, meter, kilogram, seconds, and all of that. So derived quantities on this side, these are quantities obtained by combining fundamental quantities mathematically. So when you divide or when you multiply fundamental quantities together, you are going to have derived quantities. So examples: area meter square, volume meter cube, speed meters per second, density kilogram per meter cube, and force Newton. Right? So all these ones you have here, they have their own units actually. So their units, for example, please note that the units I'm writing beside them are the SI units. So seconds, temperature, that is Kelvin, amount of substance, that is mole. Can we hear me? Luminous intensity, that is candela. Electric current, that is ampere. Hello, can we hear me?
Yes, sir.
Oh, okay. So right beside them there you see the unit in brackets: kilogram, meters, seconds, Kelvin there, mole, candela here. This is candela, and then electric current. So those are quantities. So they also have dimensions which you need to know. Dimensions, let me see if it's part of the slide there or maybe at the end of the presentation. So let's just continue with the presentation. So fundamental quantities and SI units. So for length, mass, and time, you can see their units there: meter, kilogram, seconds. For temperature, current, and mole, you have Kelvin, ampere, and mole, MOL. And for luminous intensity and some other derived units, you have luminous intensity, which is candela, CD. And then derived unit examples. So area is obtained by multiplying length with length. That's length times length. So the units for that will be meters multiplied with meters, that's meter square. Speed, that is obtained by dividing length with time. That is, speed is equals to length over time. So you have that to be meters per second. Force, this Newton here is equivalent to kilograms meters per second square. So that's kg ms raised to the power of -2. We are still going to talk more about that in detail. And for density, that's kilogram per meter cube. So all of these are quantities and SI units. So prefixes and some instruments. So prefixes of units and measuring instruments. So why prefixes? Sometimes quantities are very large or very small. So with the use of prefix, it helps to simplify the measurements. So example, 1 kilometers is 1000 meters, 1 centimeters is 0.01 meters, 1 millimeters, you have that to be 0.001 meters. So you have kilo here, which is you have kilo, which is 1000. You have mega, which is 10 raised to the power of 6, that's 1 million. You have centi, which is 1 divided by 100, and milli, which is 1 divided by 1000. You have micro, which is 1 divided by a mega. That is the inverse of mega. So mega micro. So this one is inverse of mega. So 1 divided by 1 million. So these are some quantities and measurements that we use, instruments rather, that we use to take their measurement. So length, we can use meter rule, we use tape measure, we can use vernier calipers, we can use micrometer, screw gauge, with each of them having varying varying level of accuracies. Yes. Mass, we can use beam balance for measure, we can use electronic balance to measure, and also spring balance is meant to be here as well. Electric current, you can use ammeter. Yes, you use ammeter. Time, you use clock. Yes. For example, if you were asked at home that what says the time, you can use clock, you can use stopwatch as well. Yes. Time, temperature, you use thermometer for the measurement for that. So I think we are about to end this presentation. So kind of an activity and evaluation. So match the instruments, length of classroom, you use tape rule, measure temperature of water, you can use thermometer to measure that. Time for a race, you use stopwatch. Mass of a book, you use balance. So what is measurements? We've gone through all of that. So that's just a quick run through of what we've been talking about. So yes, by the end of the session, we should be able to give a summary and also a kind of an assignment of something to work on. So that will be it for the presentation. So we go fully to the whiteboard. Are we together?
Yes, sir.
Okay, so we'll be working more on this whiteboard right now. So we are done with the basic presentation. So right here we've written out the fundamental quantities that we have. So I mentioned earlier that they also have dimensions. So talking about dimensions, dimensions usually is just at times it can be taken as the capital letters of these fundamental quantities that you have there, or if not taken as capital letter, we could use some special letters to represent the fundamental quantity, which I would explain right here. So MLT, N, J, theta, 1 2 3 4 5 6 7, and I. So these are dimensions of all of these 7 fundamental quantities that I have on the other side of the whiteboard. So this one, the M, which you must know is for mass. This L is for length. This T here is for time. N is for amount of what? Amount of substance, right? This J that you have here is for luminous intensity. Okay, this one, I hope you can see what I'm writing on the whiteboard.
Yes, sir.
Is for temperature, and I is for electric what? Electric current. So the whole of this one just summarize to you dimensions of each of those 7 fundamental quantities. Now remember we mentioned that derived quantities are obtained from these fundamental quantities simply by either multiplication or division of any of these quantities here. please do know that addition or subtraction does not give any changes of any of the units. Are we getting it? Suppose you have 7 kilograms, for example. You can only add this 7 kilograms with a quantity, with a physical quantity that is exactly this of the same unit. So meaning that you can only add 7 kilograms with, let's say, something of the same units, let's say 8 kilograms, for example, which would give you 15 kilograms, right? So you can see here that addition does not give any change in units, so it's still the same units you are going to arrive at. But suppose you have, okay, and also be aware that you can't add different physical quantities together. You can't say 7 kilogram in addition to 2 meters. Is that possible? No, that is not going to give you a definite result, because they are not of the same kind. Do you understand what I'm trying to say? Do you understand what I'm trying to say? No result.
Yes, sir.
Okay, but you can definitely multiply 7 kilogram with 2 meters, and that should give you something which is 14 kilogram meter, a particular unit. So this one that you have here, this kilogram meter, kilogram meter. So this kilogram meter that you have here is said to be a what? A derived unit. Is a derived unit. So the unit of the fundamental quantities is what we call the fundamental units. Now, okay, let's look at some derived quantities. For example, let's look at some derived quantities. For example, area is actually multiplication of length with length, as you can see here. So length is measured in meter, that's a multiplication with length as well, that is in meters. So all of these ones give you meter square, right? Also, let's say you take volume, for example. Volume is equals to length with breadth with height. So all of these measured in meters, multiply with meters, which we are going to have the unit to be meters cube, right? Now, that is units for volume. How about something like speed? To know a particular derived unit, you must know what is the formula of that particular quantity. So speed, for example, you know that it is distance divided by time. That's distance over time. So distance is just how, to what extent have you traveled, or how long a journey is. So if you want to measure, you can use something like meter rule, tape rule to measure and all of that. So which means that your units must be meters. Y for time, yes, seconds. These are SI units, right? So this one, the unit is what? Meters per second, which you can also write this way: ms raised to the power of -1. Are we still together? Force.
Yes, sir.
Thank you.
Yes, sir.
Force, which is multiplication of mass with what? With acceleration. So, as I've said earlier, you must know each of the, you must know the formula that governs the quantity you want to deal with. So I'm still going to write that mass multiplied acceleration can be further divided to uh, length over time square. Do you understand? Length over time square. So, or let me say this acceleration that you have here is equal, acceleration is equal to velocity over time, and velocity itself is simply like speed, which is length over time, that's velocity, divided by the time that you have down there in the denominator. So that is how I got this length over time square, because the time will come to the denominator to multiply. So you have what you have here. So mass, that is kilograms, multiply with length, that is meters, divided by time, that is second square. So at the end of the day, you have this to be kilograms meters per second square. So I use this, or write it as kilogram meter per second square. So for this force here, this kilograms meter per second square is what we now call Newton, which is equivalent to 1 Newton. Newton is just a unit that is used after the man that, after Isaac Newton actually. So maybe to honor him or something like that, I don't know. So that's for that one. Let's look into more examples and then we move away from here. So pressure, we have pressure to be force per unit area, as force per unit area. So your force which you've obtained up there, this is force here. So that is kilograms meter per second square divided by area. That is, area is what again? Sorry. To know that we are following, area is what?
Meter square.
Meter square. Thank
Meter
you.
square.
So
Meter square.
thank you. So this is something like kilograms meters per second square divided by meters multiplied with meters. So this is going to cancel out one of this one here. So at the end of the day, you have your units to be kilogram per second square over meter. So in physics, that over meter becomes kilograms per meter per second square. So we'll stop here for some units derivations. Now I've mentioned there that oh yes, dimension, we did not forget, please. We've just written out the units. How about the dimensions? Very important. So dimensions at times can be easily gotten from the units. Not at times, and let me say at times can be gotten from the units, because not every time you'll be able to get dimension from the actual units. Yes, which of course you are going to see some examples as we progress. Oh, I think we are running out of time. Let me check the remaining time there. Okay, the call will end soon. Okay, so once the call ends, I'm going to send a new link to the group so that you can rejoin. Okay, can we all hear me?
Yes, sir.
Yes, sir.
Okay, or
Yes, sir.
if possible, let's. Oh, she's not on the group. How did she join this one? Amira, how did you join? Let's just generate the group, the link quickly and send, because this one we end soon now. So
So,
Amira, what did you say?
share group now.
You said you are not in the group, right? Oh, how did you join this session?
The Blamid.
Oh. Okay. Uh, okay. Let me see if I can just drop it on the chats, something there, so that you'll be able to access it from there. I'm coming. Oh, someone to join.